Welcome to this section on Amazon S3. So this section is very important because Amazon S3 is one of the main building blocks of AWS. And the way it's advertised is that it's infinitely scaling storage. So as a matter of fact, a lot of the web relies on Amazon S3. For example, many websites use Amazon S3 as a backbone. And many AWS services will also use Amazon S3 for integrations as well. So in this section, we'll have a step-by-step approach to Amazon S3 to learn the main features. So there are so many use cases for Amazon S3 because at its core it is storage. So Amazon S3 is used for backup and storage. It could be for your files, it could be for your disks and so on. For disaster recovery purposes, for example, you will move your data to another region. In case a region goes down, then your data is backed up somewhere else. It's for archival purposes, so you can archive files in Amazon S3 and retrieve it at a later stage for much, much cheaper. For hybrid cloud storage, so in case you have storage on premises, but you want to expand it into the cloud, you can use Amazon S3 for this. To host applications, to host media such as video files, images, and so on. To have a data lake, so to store a lot of data and to perform big data analytics. For delivering software updates, for hosting static websites, and so on. And two use cases is that the NASDAQ stores 7 years of data into the S3 Glacier service, which is like the archival service of Amazon S3. And Cisco runs analytics on its data and gains business insights from Amazon S3. So Amazon S3 stores files into buckets, and buckets can be seen as top-level directories. And actually, the files in these S3 buckets are called objects. And these buckets, they are created in your account and they must have a globally unique name. That means that the name must be unique across all the regions you have in your account, but also all the accounts that exist out there on AWS. Okay, so this is the only thing that must be globally unique in AWS. And the buckets are defined at the region level. So even though the name of the bucket is unique across all regions and all accounts, the buckets must be defined in a specific AWS regions. So S3 looks like a global service, but the buckets are actually created in a region, and that is a common mistake for beginners. So there's a naming convention for S3 buckets. You don't need to remember it, but it's good to know. So bucket names must have no uppercase, no underscore. They must be between 3 and 63 characters long. They must not be an IP. They must start with a lowercase number or lowercase letter, and then there are some prefix restrictions. So as long as you use letters and numbers and hyphens, you're good to go. Okay, so now let's talk about objects. So these objects, they're files and they have what's called a key. And an Amazon S3 object key is the full path of your file. So if you look at my bucket, this is the top level directory, then the key of myfile.txt is myfile.txt. But in case you want to nest it in what we call folders, then the key is going to be the full path. So my folder 1 / another folder / myfile.txt. Therefore, the key is composed of a prefix and then an object name. So we can, for example, decompose the path from before into the prefix, which is my folder 1 and another folder, and the object name, which is myfile.txt. So Amazon S3 does not have a concept of directories per se, although when you look in the console, the UI, you will think otherwise and you will actually create directories. But anything and everything in Amazon S3 is actually a key. And keys are just very, very long names that contain slashes, and keys are made of a prefix and an object name. Okay, so the objects, then what are they? Well, the values are the content of the body. So you can upload a file, you can upload whatever you want into Amazon S3. So the max object size is 5 terabytes. So this is 5,000 gigabytes. And if you upload a file that is very big, and if that file is greater than 5 gigabytes, so a big file, okay, then you must use the multi-part upload to upload that file into several parts. So if you have a file of 5 terabytes, then you must upload at least 1,000 parts of 5 gigabytes. Now, the objects can also have metadata. They're list of key and value pairs, and that could be set by the system or set by the user to indicate some elements about the file, some metadata. Their tags, for example, their Unicode key and value pairs up to 10, they're very useful for security and life cycles. And sometimes the object will have a version ID if you have enabled versioning. So that's it for an introduction to Amazon S3. I'm sure you're curious about how that works, so let's go in the console to get started. So here I am in the Amazon S3 console, and the first thing I'm going to do is, of course, to create a bucket, because this is where the data is being stored. So the bucket name has to have a name, and if I enter a name that someone has already taken from before, for example, if I enter test and leave this box, and I try to create this bucket, I'm going to get an issue saying that the bucket with the same name already exists. So even though in my account, I've never created a bucket named test, someone in someone's account has created a bucket named test, and it's already taken. And so therefore, I cannot name my bucket like this. So instead, I will name this Stéphane Demo S3, something like this. And perfect, this bucket name should not have been taken before. We'll have a look at it when I create this bucket, but it should be unique. Next, if we have a look, there is a region this bucket needs to be into. So I'm choosing a region that is close to me, for example, the Ireland region, and you can choose a region that is close to you. But you will notice on the right-hand side, on the top right, that the console says that it's a global selection for the Amazon S3 service. So that means that within the S3 service, you will see your buckets across all regions in one view. But remember that your buckets are not global. Your buckets are created and live only within one region. Okay, perfect. So we have a name, we have a region. For object ownership, we're going to disable the ACLs for now. I will not go over the setting. There's another security setting here to block all public access. We will leave this on by default. Same for versioning, we'll leave the disabled by default. And for default encryption, I will leave the default settings. So we'll just go ahead and create a bucket with these settings set as defaults. So now, as you can see, I've successfully created my bucket Stéphane Demo S3, and it's here in my bucket view. So again, we have in this view access to all the buckets because we're in the global setting, but each bucket is assigned to a specific region. Okay, so next, let's go into this bucket and close the left-hand side panel. And now in my bucket, I would like to start uploading objects because currently I have 0 objects. So let's click on upload, and then we can add files. And I'll navigate into your code, go into the S3 folder, and then you will find a coffee.jpg file. So choose this coffee.jpg file. As you can see, it's an image JPEG. It has 100 kilobytes in size. And then the destination is S3 Stéphane Demo, which is my bucket. Okay, so let's upload this file. We're done. So I can close this on the right-hand side. And now back into my S3 bucket, I can see that the coffee.jpg file is under my objects. So what I can do is now click on it and have more details around that file. So now that we are in the object page, we can have a look at a bunch of overviews. So a bunch of properties, where it's been uploaded, the size, the type, and there's an object URL here. We'll be playing it in a moment. So how do we do this? So now we want to open this object and see if we can open it. We can view it because we have uploaded it onto our Amazon S3 buckets. Therefore, I'm going to click on open. And if I do click on open, as you can see, I can see my coffee.jpg file. So this is the one I have uploaded, and it is on the internet. Awesome, right? But if I go back to my overview and click on this object URL right here, so I copy it, I paste it, and I enter it, as you can see, I get an access denied. And this access denied tells me that I cannot access my object using what's called the public URL. So as you can see here, this public URL is not working, but this URL is working. So what's the difference? Well, this URL right here, if you have a look at it, the beginning is exactly the same, but then the rest is a very, very complicated and long URL because it's called an S3 pre-signed URL. Why? Well, because this URL contains actually a signature that verifies that I am the one making the request, and therefore it has my credentials in it. And so because my credentials are encoded in this URL, then Amazon S3 says, well, Stéphane is allowed to view his own object, therefore I will display it. So this public URL does not work, but this pre-signed URL with my own credentials works. And obviously, this URL is only for me. So we'll see how to make that object public later on so that the public URL will function as well. So let's go back into our bucket, the Stéphane Demo S3. And I have one object, but I can create a folder. And this folder name may be called images. So we scroll down and create this folder. So now I have the images folder in my bucket. I can click on it And within it, I can upload again a file. And this time I will upload the beach.jpg file into, as you can see, the destination is my images folder within my S3 bucket. So let's upload this, close this. As we can see now, we have the beach.jpg object within the images folder. And if I go one level up, we can see the folder here. So this looks just like, the cloud storage service you used to know, such as Google Drive or Dropbox or whatever you want. Here we have something very similar in terms of the user experience on Amazon S3. So of course I can go to images and I can delete this folder entirely. So this will delete everything within the folder. And to delete things, I just type permanently delete into the text input, delete my objects, and I'm good to go. So that's it for this lecture. We've seen how we can upload objects into Amazon S3. We've seen how we can open them in two different ways, creating folders, deleting folders, and so on. So I hope you liked it, and I will see you in the next lecture. So now let's talk about Amazon S3 security. The first part is user-based. So as a user, you can have IAM policies attached to you, and this IAM policy is going to authorize which API calls should be allowed for a specific IAM user. You can also have resource-based security. So this is new. We can use what's called S3 bucket policies. And there are bucket-wide rules that you can assign directly from the S3 console. And this will allow, for example, a specific user to come in or allow a user from another account, this is called cross-account, to access your S3 buckets. This is also how we'll make our S3 bucket public, as I will show you in a minute. Next, you have the Object Access Control List, or ACL. They're fine-grained security, and they can be disabled. And if you want to go at the bucket level, you can have Bucket ACL, which is way less common, also can be disabled. And the most common way now to do security on an Amazon S3 bucket is to use bucket policies. So in which situation can an IAM principal can access an S3 object? Well, if the IAM permissions allow it, or if the resource policies allows it, and that there is no explicit deny in the action, then the IAM principal can access the S3 object on the specified API call. So we'll have a look at these use cases in a minute. Finally, another way to do security on Amazon S3 is to encrypt the objects using encryption keys. So what does a S3 bucket policy actually look like? Because this is the focus of S3 security for us. So they are JSON-based policies, and they look like this. So this is a JSON document, and it's quite easy to read. So the first thing is that you have a resource block, and the resource tells the policy what buckets and object this policy applies on. And here we can see that this applies to every object within the example bucket. This is what the star is for. Next, we have the effects, so allow or deny. And what do we allow or deny? Well, we deny actions. So we have a set of APIs we can either allow or deny. And in this example, the action we allow is get object. So this allows anyone, thanks to the principal. The principal represents the account or the user to apply the policy to. So principal is star. So here we allow anyone with a star to get objects, so to retrieve an object from my example bucket with a star. That means any object within it. So therefore, this S3 bucket is setting public reads on all objects inside my buckets. So we can use an S3 bucket policy to grant public access to the bucket, as the one shown on the right-hand side, or to force objects to be encrypted at upload, or to grant access to another account. So let's have a look at the situation. So here is a bucket policy for public access. So we have a user, it's on the World Wide Web, it's a website visitor, and he wants to access files within our S3 buckets. So we'll attach an S3 bucket policy that allows public access. This is the one you've seen in the previous slide. And once this bucket policy is attached to the S3 bucket, then we can access any objects within it. That's what we'll see in the hands-on. But another way to do it is that if you have a user within your account, so it's an IAM user, and that user wants to access Amazon S3, then we can assign IAM permissions to that user through a policy. And therefore, because the policy allows access to the S3 bucket, then the user can access our S3 bucket right now. If we have an EC2 instance and want to give access from the EC2 instance into the S3 buckets, we've seen that IAM users are not appropriate. We need to use IAM roles instead. So we create an EC2 instance role with the correct IAM permissions, and that EC2 instance will be able to access the Amazon S3 buckets. More advanced, if we want to allow cross-account access, then we must use a bucket policy. So we have an IAM user in another AWS account, and we create an S3 bucket policy that allows cross-account access for that specific IAM user, and therefore the IAM user will be able to make API calls into our S3 buckets. Other security settings you need to know about is that there is the bucket settings for block public access. So this is what we set to on when we created the bucket. And these settings were invented by AWS as an extra layer of security to prevent company data leaks. So even though you would set an S3 bucket policy that would make it public, if these settings are enabled, the bucket will never be public. So this is to prevent data leaks. So if you know that your bucket should never be public, then leave these settings on and you have a level of security against people who would set the wrong S3 bucket policy. And if you know that none of your S3 buckets ever should be public, then you can set this at the account level. Okay, so that's it for S3 security. Now let's go in the hands-on to practice. So let's go ahead and make a bucket policy so that we can access this coffee file from the public URL. So to do so, let's go under the permissions tabs. And the first thing we have to do is to allow public access from the bucket setting, because right now everything is blocked. So we edit this and we're going to untick this, and therefore we will allow public access. But again, this is something you would disable only and only if you know you want to set a public bucket policy. So this is dangerous action. So we say yes, because of course, if you set data, real data of your company on an S3 bucket and you make this public, you have data leaks and that can never be good. So now under permissions overview, the access is that objects can be public. So that's the first step. Next, we scroll down and we look at bucket policy. So currently we have none and we want to create one so that we make our entire bucket public. So the first thing you can do is look at the policies example, and this is the documentation, and it will show you a lot of use cases on the right-hand side that will show you what's the appropriate and corresponding bucket policy. But for us, we're going to use the policy generator. So here is the AWS policy generator, and we're going to create an S3 bucket policy. So let's select the right type. We'll allow, and then the principal is going to be a star because we want to allow anyone on the Amazon S3 service to perform, and because we read objects on our bucket, we want to perform a get object. So here it is. We want to allow get objects, and the Amazon resource name must be the bucket name with a slash and then with a star. So let's have a look first. So back into our S3 buckets, we have the bucket ARN here, the Amazon resource name here. So we copy it, we paste it into the Amazon resource name, and this is not over. We add a slash and then we add a star. And the reason why we do this is that this action, the get object action right here, applies to objects within your buckets. And therefore, objects within your bucket are after a slash and their stars to represent these objects. So let's add this statement and then let's generate this policy. And this policy is what we copy into here. And this is a public S3 policy. So that means that get objects are allowed from anyone on any objects of this bucket. Okay, that's good. So let's save these changes. And there is a space here, so let's remove this. Perfect. Save these changes. Now that works. And now, as you can see, under permissions overview, the access is now set to public. And we get a little warning that unless you want this to be really accessible from the internet, then don't do this. Okay, so now it's publicly accessible. We can see it really from everywhere. So if we go back into our coffee.jpg file, this is the public URL, okay? The full public URL. And I'm going to refresh this page. And now, as you can see, the coffee.jpg file appears before my screen. And therefore, that object is now public. And any objects uploaded onto our Amazon S3 bucket is now going to be accessible using the public URL. Okay, so that's it for this lecture. We've had an overview of bucket policies and as well as a sneak peek into the policy generator. I hope you liked it, and I will see you in the next lecture. So now let's talk about how Amazon S3 can be used to create a static website. So S3 can host static websites and have them accessible on the internet. And the website URL will be, depending on the AWS region where you create this, either this or that. And they look very, very similar, as you can tell, but the only difference is that here you have a dash and here you have a dot. It doesn't really matter for you to remember this, but just so you know, here it is. So we have an S3 bucket and it will contain files, maybe HTML files, maybe images, and then we're going to enable this to be compatible with hosting a website. So this is what it will look like with the corresponding URL. And then the user will access our S3 buckets. But this will not work if we don't have public reads enabled on our S3 bucket. And this is why in the first place, in the last lecture, we learned about S3 bucket policies. So if you have a 403 forbidden error after enabling your S3 bucket for reads, then that means that your bucket is not public. And therefore, you must attach an S3 bucket policy that allows it to be public. So that's it for this short lecture. Now let's go into the hands-on to practice this. Okay, so let's enable our bucket to be a website. But first, I'm going to upload one more file here. I'm going to upload my beach.jpg file into our buckets. Okay, this is done. So we have two files into our buckets. And let's go into properties, scroll down, and all the way down, you will find the static website hosting. So click on edit, and here we will enable static website hosting. We want to host a static website, and we need to specify an index document. So I will say index.html, and we will have to upload that file. This is the default or homepage of the website. As you can see here, we also have a little warning sign saying, hey, by the way, if you want to enable this as a website endpoint, you must make all your content publicly readable. And we've done this in the previous lecture, so that's good. Okay, so let's go and save this. So this is saved, and go back into our objects. And the one thing that's missing here is that index.html file. So let's go to upload this. We add files, and then I will click on index.html and then upload, close it. It's created. So now back into properties. Let's scroll all the way down. And you see now that under static website hosting, we have a bucket website endpoint. So I copy this URL, paste it, and I get I love coffee, hello world, and my coffee.jpg file. So this working. So this is my index.html file. And if I right click on this and open this image in a new tab, we have the public URL of our coffee.jpg. So this is working. And by the way, if we wanted to change the coffee for beach, well, under beach.jpg, we can see as well this beach image right here. So that means that everything is working. Our S3 bucket is enabled for static website hosting. And thanks to the S3 bucket policy being public, we can see all these files. So we're good to go. I hope you liked this lecture, and I will see you in the next lecture. So now let's talk about versioning in Amazon S3, because we've seen how to create a website, but it would be nice to be able to update it in a safe way. So you can version your files in Amazon S3, and this is a setting you have to enable at the bucket level. So we have my bucket, and it's enabled with versioning. So whenever a user uploads a file, it's going to create a version of that file at the selected key. And then should we re-upload the same key, should we overwrite that file, then instead it's going to create a version 2, and then a version 3, and so on. So therefore, it is best practice to version your buckets. Why? Well, the first thing is that it protects against unintended deletes. So for example, if you delete a file version, actually you just add a delete marker, and therefore you can restore versions that were previously there instead. You can also easily roll back to a previous version. So if you want to go back to what happened 2 days ago, you can take a file and roll it back. So there are some notes you need to be aware of. First of all, that any file that is not versioned prior to enabling versioning will have the version null. And also that if you suspend versioning, it does not delete the previous version. So it's a safe operation. Okay, so now let's go in the console and have a look at how we can use versioning. So now let's play with S3 versioning. And so first you need to go into the properties. And then we have a bucket versioning setting. We're going to edit this and we're going to enable it. And this is to enable bucket versioning. And therefore, any files we overwrite now is just going to add versions into our buckets. So this is good. Let's go into our objects and say we want to update our website. So let's go back, find the website URL. It is right here. Okay, so we have I love coffee, but let's say we want to write I really love coffee. So therefore, let's go back into here, our file, and I'm going to edit it and say I really love coffee. I've saved it. And now I upload this file again. So I'm going to add a file and it will be my index.html. And now we have updated content in that file. So if I upload it, it's successful. So now it's been overwritten. if I go into my first web page and refresh this, I get I really love coffee. But what did happen in the back? Well, if we go here and we have here this toggle show versions, we're going to show the actual version ID with the files. And so we can notice a few things. Number one, the files that we had uploaded before, such as the beach.jpg and the coffee.jpg, have a null version ID. That's because they were uploaded before we had enabled versioning. But this file index.html, as you can see, has two versions. One has version ID null, which is the file we had uploaded before enabling versioning. But the file we uploaded just right now has a version ID. And therefore, by updating this file and uploading it into our S3 bucket, we have created a new version ID. So this is something you can only see if you enable this toggle. So now, thanks to versioning, what we can do is we can actually roll back our page. So we have I really love coffee, but we want to go back to I love coffee. So how do we do this? Well, we click on this specific version ID. Okay, so make sure that show versions is enabled, and then we're going to delete. And here we have to delete a specific version ID of our object. And therefore, when we delete a specific version ID of our object, it's called a permanent delete. So it's a destructive operation. It cannot be undone. And so if we're sure, we type permanently delete in this text box and click on delete objects. And now if we go back, as we can see, we are back with the previous state of our bucket. And therefore, if I refresh this page, I just get I love coffee. But what if we disable show versions? So now we just have our objects. And I'm going to take this coffee.jpg file and I will delete it itself. So this time we don't actually delete the underlying version ID. We delete by adding a delete marker. And so it doesn't actually delete the underlying object, as we'll see. So let's just type delete this time. It's not permanently delete, it's just delete. And we delete the object. Perfect. So now if we have a look at it from within our bucket, it looks like the coffee.jpg file is done. But if we click on show versions, we see that we have a delete marker on our coffee.jpg file with this version ID. And the previous at least, coffee.jpg file is still in our bucket, but it's being overwritten, at least right now from a version perspective, by a delete marker. So back into our web page, if I refresh this page and I refresh it by forcing a refresh, by doing Command Shift R to force a refresh, then we see that the image is not available. So how do we get back this image? And if I just try to, for example, open this image in a new tab, it doesn't work. I get a 404 not found. So instead, to get back the previous objects, I can click on this delete marker and I'm going to delete the delete marker. So I will permanently delete this delete marker. And the effect of that is that it will restore the previous version of my object, which is this one from before. So back into my web page, if I refresh it now, we can see that the coffee.jpg file is there. So you can play around with versioning. You can add as many file versions as you want. You can start deleting them and view what happens. But I hope you like this lecture, and I will see you in the next lecture. Now let's talk about Amazon S3 replication, and there are two flavors of it. So CRR is for cross-region replication, and SRR is for same region replication. The idea is that we have an S3 bucket in one region and a target S3 bucket in another region, and we want to set up asynchronous replication between these two buckets. So to do so, we first must enable versioning in the source and the destination buckets. And if we do CRR, so cross-region replication, the two regions must be different. If we do SRR, the two regions are the same. Now it's possible for you to have these buckets in different AWS accounts, and copying happens asynchronously. So the replication mechanism happens behind the scenes in the background. And to make replication work, you must give proper IAM permissions to the S3 service so that it has the permission to read and write from specified buckets. So the use cases for replication are manifold. The first one is that if you use cross-region replication, this can be helpful for compliance or for providing lower latency access to your data because it's in another region, or to replicate data across accounts. For SR, so same region replication, this can be very helpful to aggregate logs across multiple S3 buckets, or to perform a live replication between a production and test accounts, so you have your own test environment. Okay, so that's it about replication. I will see you in the next lecture for some practice. So let's practice replication on Amazon S3. For this, we're going to create a new bucket. I'll call it S3 Stéphane bucket origin v2. and I will set it in one region that I want, for example, EU West 1. This will be my origin bucket, and then data will be replicated from this bucket to another bucket. So the thing I need to do, of course, is to enable versioning, because replication only works if versioning is enabled. So I will create this bucket, and then open this bucket in a new tab, and I will create a second bucket, and this will be my target bucket. So I will do S3 Stéphane bucket replication or replica v2. And this time the region can be either the same, for example, if you wanted to do same region replication, or something completely different. For example, if you wanted the US, you could do US East 1 to replicate from Europe to the US. Okay, so let's scroll down and let's again enable bucket versioning on the target buckets. And we're good to go. So now we have our primary bucket and our secondary buckets. What I'm going to do is that in the origin bucket, I'm going to upload a file. So I will add a file of my beach, for example, beach.jpg. Okay, this is done, and we can close this. So now this has one file, but of course, this does not get replicated yet because we haven't set up replication yet. So let's go ahead and do this. So on the origin bucket, what I need to do is to go under management, scroll down, and there are replication rules, currently 0. So let's go ahead and create our first replication rule. So I'll call this one demo replication rule. Okay, perfect. We'll set it as enabled. For the source bucket, we'll leave it as is, and in terms of rule scope, we'll apply it to all objects in the bucket. Now for the destination, we can specify a bucket in this account or another account, and we'll choose one in this account, and the bucket name is my target bucket. So I need to actually enter the name. So I will take this bucket right here, copy and paste it. Okay, and as you can see, the destination region was identified as being US East 1. So therefore, this is a cross-region replication. Okay, now for IAM role, we need to actually go and create a new role for this. So here's the option. And then we can have a look at some settings, but for now, it doesn't really matter for us. Let's just save this. So we get a prompt right here, which says, do you want to replicate existing objects? So it turns out that when you do enable replication, it will only replicate objects from the moment you set it. So for newer uploads. So if you wanted to replicate the previous objects from the source to the destination bucket, you could use something called a batch operation, an S3 batch operation to do so, and you would need to say, yes, replicate existing objects. But this is separate from the replication feature itself. Therefore, I'm going to say no, do not replicate existing objects, and we're good to go. So now let's have a look. So we have this management with a replication rule that is ready. And now what I'm going to do is check in my replica bucket. Of course, if I refresh now, we see that the objects haven't been replicated. So what I'm going to do is now upload a new file. For example, upload the coffee.jpg file, upload it. We're done. So here is the coffee.jpg file. Let's show the version. So this is coffee.jpg and the version is GBK. Okay, perfect. Now if we go in my target bucket and refresh this, it's going to take maybe 5 seconds. And this took about 10 seconds on the first replication, but we can see that my coffee.jpg has been added into my replica bucket. And if I show the versions, we can see that the version ID of my coffee.jpg is the exact same of the origin bucket. So the versions IDs are replicated, which is great. And if I wanted to port the beach.jpg, I would need to upload a new version of that file. So let's upload beach.jpg again. Now this has been uploaded. We can look at the version. So there's a new version right here of DK2 of my beach.jpg file. And now if I go here and refresh, and this took a bit of time, but as you can see, you can find the DK2 version of that file. So that's it for S3 bucket replication. I hope you liked it, and I will see you in the next lecture. Okay, so let's discuss the different storage classes we have for Amazon S3. The first one is Amazon S3 Standard, general purpose. Then we have Amazon S3 Infrequent Access. Then we have Amazon S3 One Zone Infrequent Access. Then we have Glacier Instant Retrieval, Glacier Flexible Retrieval, Glacier Deep Archive, And then finally, the Amazon S3 intelligent tiering. So we'll learn about all these classes in depth in this lecture, but you have to know them for the exam. Then when you create an object in Amazon S3, you can choose its class. You can also modify its storage class manually. Or as we'll see as well, you can use Amazon S3 lifecycle configurations to move objects automatically between all these storage classes. So first, before we go into the classes, let's define the concept of durability and availability. So durability represents how many times an object is going to be lost by Amazon S3. And so Amazon S3 has a very high durability. It's called 11.9, so 99 point and then 9 times 9%. And that means that on average, if you store 10 million objects on Amazon S3, you can expect to lose a single object once every 10,000 years. So it's quite durable. And the durability is the same for all storage classes in Amazon S3. Availability represents how readily a service is. And so this depends on the storage class. For example, S3 standard has a 99.99% availability. That means that about 53 minutes a year, the service is not going to be available. That means that you will get some errors when you deal with the service. So you need to take that into account when you develop your applications. Okay, so S3 standard has 99.99 availability. It's going to be used for frequently accessed data. This is the kind of storage you use by default. And it has low latency and high throughput. It can sustain 2 concurrent facility failures on the side of AWS. And the use cases for it is going to be big data analytics, mobile and gaming application, as well as content distribution. Next, we have S3 infrequent access. So this is data that is going to be, as the name indicates, less frequently accessed, but requires rapid access when needed. It's going to be lower cost than S3 standard, but you will have a cost on retrieval. So the S3 standard IA is 99.9% availability, so a bit less available. And the use case for it is going to be disaster recovery and backups. And Amazon S3 one zone infrequent access, one zone IA, has high durability, okay, within a single AZ only. And the data is going to be lost if the AZ is somewhat destroyed. As well as durability, it's even lower, so it's 99.5% availability. And so the use cases of S3 one zone IA is to store secondary copies of backups of maybe on-premises data or data you can recreate. Next, we have the Glacier storage classes. So Glacier is, as the name indicates, very cold. So it's low-cost object storage meant for archiving and backup. And the pricing is that you're going to pay per the storage plus pay for a retrieval cost. And you have 3 classes of storage within Glacier. You have the Amazon S3 Glacier Instant Retrieval. And this gives you milliseconds retrieval, which is great, for example, for data that's accessed once a quarter. And the minimum storage duration is 90 days. So this is backup, but you need to access it within milliseconds. Then we have the Glacier Flexible Retrieval. It used to be called Amazon S3 Glacier, but then they renamed things as they added more tier. So the Amazon Glacier Flexible Retrieval has 3 flexibilities. So you have expedited, where you get the data back between 1 and 5 minutes. You have standard, to get the data back between 3 to 5 hours, or bulk, which is free, where you get the data back between 5 to 12 hours. And the minimum storage duration as well is 90 days. So here, instant means you retrieve the data instantly, and flexible means that you're willing to wait up to, for example, 12 hours to retrieve your data. And then we have Glacier Deep Archive, which is meant for long-term storage. So we have 2 tiers of retrieval as well. We have standard of 12 hours and bulk of 48 hours. So you may be ready to wait a lot of time to retrieve your data, but it's going to give you the lowest cost, and as well, the minimum storage duration is 180 days. So as you know, that's a lot of storage classes, and there's one last called S3 Intelligent Tiering, which is going to allow you to move objects between access tiers based on usage patterns. And for this, you're going to incur a small monthly monitoring fee and auto tiering fee. And there are no retrieval charges in S3 Intelligent Tiering. So there is the frequent access tier, that's automatic, that's the default tier. Then we have the infrequent access tier for objects not accessed, for example, for 30 days. Then you have the archive instant access tier, automatic as well, for objects not accessed over 90 days. And then the archive access tier, that's optional, and you can configure it from 90 days to 700 plus days. And then you have the deep archive access tier, also optional, that you can configure for objects that haven't been accessed between 180 days to 700 plus days, okay? So S3 Intelligent Tiering is really to allow you to just sit back and relax while S3 moves objects for you. So if we compare all the storage classes, you don't need to remember these numbers, but it's just for you to make sense of what they are. So you get durability of 11 nines everywhere. Then the availability goes down the less zones you have, of course. It just shows you, like, for example, the minimum storage duration charge and so on. So take some time to look at this diagram on your own. You should understand it, but you should not remember it for sure. So if we look at some pricing, for example, in US East 1, so this is the kind of pricing you would have for all the storage classes. And again, you're not supposed to remember everything, but it's good for you to have a look at it on your own time just to make sure you understand, because if you understand what the classes' name are, then you should be able to make sense of these classes, okay? So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So let's create a new bucket in S3 and call it S3 Storage Classes Demo 2022. Okay, then I create into any kind of region, and I will go ahead and just create this bucket. So back in my bucket, I can go ahead and upload a object and click on Add Files. I will choose my coffee.jpg, and let's have a look at the options. So we can look at the properties of that object, and under storage class, I get the wide range of storage class that are for AWS objects. So we have S3 standard, okay, and we get the design for column, how many AZs we have, as well as some other columns such as the minimum storage duration, minimum billable object size, and monitoring and auto tiering fees. So let's have a look at all of them. So we have standard, which is the basic ones by default. Then we get intelligent tiering in case we don't know our data patterns, and therefore we want AWS to perform the data tiering for us. Standard IA, if we want data to be infrequently accessed, but still with low latency. One zone IA, which is that you can recreate this data and it's going to be stored in one AZ only, and therefore you can run the risk of losing the object if the AZ is destroyed. Then we have 3 Glacier levels. So we have Glacier Instant Retrieval, Glacier Flexible Retrieval, or Glacier Deep Archive, and they tell you exactly what are the conditions in here. And finally, Reduced Redundancy, which is a deprecated type of storage tier, and therefore I did not describe it in the course. So what if we go with standard IA, for example, and create an object there? So we're going there, and then we're going to say upload back in our bucket. So now this object has the storage class standard IA as it is shown here. But what I can do is that I can also change the storage class if I wanted to. So I can go into properties and scroll down, and we can actually edit the storage class to do something different. So we can move it, for example, to one zone IA, in which case this object is going to be stored in one zone only. So let's save these changes. And now my object has successfully been edited, and therefore the object class has changed. So if we scroll down, now we are in one zone IA. And again, you could edit it and go, for example, for Glacier Instant Retrieval. And now it's going to be archived. Or you can go for intelligent tiering, and it could be automatically set to the right tier based on our patterns and so on. So as you can see, there's a lot of power using storage classes. And finally, I want to show you how we can automate moving these objects between the different storage classes. So let's go back into our buckets, and there under management, you can create lifecycle rules. And you can create a rule, and we'll call this one demo rule. And then you're going to say, hey, apply to all objects in the bucket. Yeah, sure. And then we can say, okay, move current versions between storage classes. And you're saying, hey, you go to standard IA after, for example, 30 days. And then you go to intelligent tiering after 60 days. And then you would go to Glacier Flexible Retrieval after 180 days, and so on. So you get some transitions, and in here you can review all the transitions you have done. So it is possible for you to automate moving objects between tiers, okay? So that's it. We've seen everything we need to know about storage classes. I hope you liked it, and I will see you in the next lecture. So you might have one question on S3 encryption at the exam. So here is a high-level review of what that means. The first one is server-side encryption. So it is by default, whenever you create a bucket or whenever you upload an object, it will be encrypted. What is server-side encryption? Well, the user uploads an object into Amazon S3, and then that object, when it arrives in the bucket, is going to be encrypted by Amazon S3 for security purposes. The idea is that the server is doing the encryption, and therefore we call this server-side encryption. On the opposite, we have client-side encryption. This is when the user will actually take the file, will encrypt it before uploading it. So the lock is done by the user and then put it in the bucket. And that's called client-side encryption. And both models exist in AWS, but by default, you should know that server-side encryption is always on. All right, that's it. I hope you liked it, and I will see you in the next lecture. As always, it's good to see what is the shared responsibility model for Amazon S3. So AWS is going to be responsible for all the infrastructure. That includes all the things specific to S3, so the durability, the availability, the fact that it can actually sustain concurrent losses of two facilities, as well as obviously their own internal configuration and vulnerability analysis and their own compliance validation internally within their infrastructure. And you, as a user of Amazon S3, you're supposed to set up correctly S3 versioning to make sure that you set up the right S3 bucket policy so that the data is protected within your buckets. You need to make sure that if you want replication, you set it up yourself. Logging and monitoring is optional, so you have to enable it yourself. Making sure that you are using the most optimal cost, the storage class that is going to be the most cost-friendly is also your responsibility. And finally, if you wanted to encrypt your data onto your Amazon S3 bucket, that is up to you as well, okay? So here we can really see what is the difference between the responsibility of AWS and yourself in this Amazon S3 service. All right, that's it. I will see you in the next lecture. So now let's talk about the AWS Snow family. So it represents a highly secure portable devices that has two use cases within AWS. Either it's used to collect and process data at the edge or to migrate data in and out of AWS. So we have two use cases, the data migration, and for this we have three different types of devices within the Snow family. We have the Snow Cone, the Snowball Edge, and the Snowmobile. And for the second use case, edge computing, we have the Snow Cone and the Snowball Edge. So we'll first tackle the data migration subject and then the edge computing. So why do we want to do data migration with the AWS Snow family? Well, if we look at the time it takes to transfer a lot of data over the network, it can take a lot of time. So for example, if we want to transfer 100 terabytes over a 1 gigabits per second network line, it will take us 12 days to achieve it. Okay. And so obviously, if we do a petabyte, it will take forever and so on. So as we can see, sometimes we just want the data to get to AWS fast. And the challenge is that sometimes on top of having a small network transfer, you have limited connectivity, limited bandwidth, sorry. Transferring data over the network may cost you some money. Okay. It's not free to use a network. It could be that also the bandwidth is shared. For example, if you download a video from AWS and you download 10 terabytes of data, maybe you're going to block your entire office because you're maximizing the bandwidth within your office. And then maybe the connection is not stable enough, so you have to retry and so on. So all these reasons make a case for Snow family. So the Snow family are offline devices that allow you to perform data migrations. So AWS will send you an actual physical device by the post office, and then you load your data onto it, and then you send it back to AWS. So the rule of thumb is that if it takes more than a week to transfer data over the network, then you should use a Snowball device, for example. So to really explain how that works, let's take an example. If you wanted to directly upload a file into Amazon S3, we have the client sends the data into Amazon S3. Very easy, right? But with the Snow family, for example, with the Snowball device, the client requests a Snowball device. We receive it via the post, okay? AWS will deliver the device to us. We load the data directly onto the devices locally, and then we ship back the device to AWS into an AWS facility. Then they will take the device and they will plug it into their own infrastructure, and then the data will be imported or exported based on what you want to do to an Amazon S3 bucket, and you're good to go. So really, it is a way to transfer data to AWS, but through the physical route, not the network route. Okay, so now what sort of devices do we have? We have the Snowball Edge. And Snowball Edge is a huge box, as you can see, and it is going to be used to move terabytes or petabytes of data in and out of AWS. is going to be an alternative to moving data over the network, as we've seen. We're going to pay per data transfer job. And the interface within the Snowball Edge is going to provide a block storage or Amazon S3 compatible object storage. So we have two flavors for the Snowball Edge. We have the Snowball Edge Storage Optimized, which is going to give us 80 terabytes of hardware hardware disk capacity, which works for block volume or S3 compatible object storage. And we have the Snowball Edge Compute Optimized of space of 42 terabytes or 28 terabytes. So really, if we want to have more storage, obviously, we want to get the flavor that is called Snowball Edge Storage Optimized. So the use case for a Snowball Edge for data transfers so far is to do a large data cloud migration, to decommission a data center, or maybe to do disaster recovery by backing up your data into AWS. Next, we have the Snowcone. So the Snowcone is a very small portable device, and it's rugged, it's secure, it can withstand harsh environments, and it's meant for environments where you have a little amount of data. So it's light, it's like 2.1 kilograms, and you can put it on a drone if you wanted to. And it's going to be used for edge computing, storage, and data transfer. You have two flavors of it. You have the Snowcone, which comes with 8 terabytes of HDD storage, and the Snowcone SSD of 14 terabytes of SSD storage if you need a faster disk. You would use the Snowcone where the Snowball does not fit, for example, in a space-constrained environment, and you must provide your own batteries and cables. Now, to send back the data to AWS, you have two options. So either you send the data back offline by shipping it, or you can connect this device after it has captured some data into a data center, for example, whatever that has an internet connection, and then use the AWS Data Sync service to send the data back to AWS. And then Snowmobile is an actual truck. So when they announced it, they actually took a truck on stage to show that it was an actual truck that is going to transfer data. And so with the Snowmobile, you can transfer exabytes of data. So 1 exabyte is 1,000 petabytes is 1 million terabytes. And each Snowmobile will have 100 petabytes of capacity. So if you wanted to reach 1 exabyte of data, you need to order 10 Snowmobiles. It's high security, it's temperature control, there's GPS, 24/7 video surveillance, so it's quite a secure way to transfer your data. And it's a better use case than Snowball if you start transferring more than 10 petabytes of data. So as a summary, for data migration, we have 3 options. We have Snowcone, Snowball Edge, Snowmobile, and each come with different storage capacity, so 8 terabytes, 80 terabytes, and 100 petabytes. The migration size that's recommended by AWS is a Snowcone is up to 24 terabytes. For Snowball Edge, it's up to petabytes, and it's offline because you have to send it back to AWS. And for Snowmobile, the use case is up to exabytes of data. Data Sync agent is pre-installed on a Snowcone because you can plug it to a network and have Data Sync send the data over the network to AWS as well. And for Snowball Edge, you can do storage clustering, so you can put up to 15 Snowball Edges together to increase the storage size. Okay, so how do we use a Snow family device? Well, you request the device from the console for delivery, and we'll see this in the hands-on. Then we install the Snowball client, or we use AWS Ops Hub that we'll see in this lecture on your servers. Then we connect the Snowball to the servers and start copying the files in the client. Then we ship back the device when we're ready. It will go straight to the right AWS facility thanks to an e-ink marker. And the data will be loaded onto an S3 bucket. And then the Snowball will be completely wiped according to the highest security measures. So that's for the data migration. And that was originally one and the only use case for Snowball devices. But the second use case now for the Snow family is called edge computing. And so edge computing is when you process data while it's being created at an edge location. So what is an edge location? Well, an edge location is anything that really doesn't have internet or that is far away from the cloud. So for example, if you have a truck on the road, or if you have a ship on the sea, or a mining station underground, all these things can be called edge locations because they can produce data, but they may not necessarily have internet connectivity. So either limited connectivity or no internet access, or no access to computing power. And so you may still want to run computation, data processing at these locations. And for this, we need edge computing. And so to do edge computing, we can order a Snowball Edge device or a Snowcone and have it embedded into these edge locations and start doing edge computing. So the use cases of edge computing is to pre-process data, do machine learning at the edge, so without it going back to the cloud, transcode major streams in advance, and eventually, if need be, if you need to transfer the data back into AWS, you can ship back the device for your Snowcone or your Snowball Edge. So really, you start processing the data very, very close to where it's being created, and then you ship it back to AWS. So for edge computing, what do we have? We have the Snowcone, and it comes with two CPUs, 4 gigabytes of memory, has wired or wireless access, so Wi-Fi. It's powered by USB-C and and an optional battery. Then for Snowball Edge, it's compute optimized. So we have two different flavors again. So the compute optimized one has 104 vCPUs and 416 gigabytes of RAM, and an optional GPU if you wanted to do video processing or machine learning. We have up to 42 terabytes of usable storage. And for the Snowball Edge that is storage optimized, we have 40 vCPUs, 80 gigabytes of RAM, and 80 terabytes of storage. We have object storage clustering available for the storage. And all of these devices can run either EC2 instances within them or Lambda functions using the service called AWS IoT Greengrass. And if you do edge computing, then you may want to have these devices in your facilities, in your trucks, in your boats for a very long time. And so therefore, you have long-term deployment options where you can get a discounted pricing if you borrow these devices for 1 or 3 years. Finally, for the Snow family, there is UpSub. So historically, when you were using these devices, you needed a CLI, so a command line interface tool to deal with them, and it was very, very difficult. And so AWS recognizes that. And so they've created UpSub, which is a software that you install on your computer or laptop. So it's not something you use on the cloud, it's something you have to download on your computer. And then once it's connected, it's going to give you a graphical interface to connect to your Snow devices and configure them and use them, which is very, very handy. So this allows you to do unlocking and configuring single or cluster devices, transferring files, launching and managing instances, so EC2 instances running on Snow family devices, monitor device metrics, and launch compatible AWS services on your devices, for example, EC2 instances, use data sync, or a network file system. So that's it for the Snow family. I hope you liked it, and I will see you in the next lecture. So let's have a look at the AWS Snow family service. So from the console, you can actually order a Snow family device, and you have to name your job, for example, demo job. So we need to choose a job type so we can import data into Amazon S3, which is the most common use case. We can also export data from Amazon S3. You can order a Snow device just for local compute and storage only. This gives you some kind of device, that server that can run in a remote place without being connected to the internet. Or you can import virtual types into the AWS storage gateway. So we'll choose the first option, import into Amazon S3. And here we have several options for Snow devices. So we have Snowcone, Snowcone SSD, Snowball Edge storage optimized with 80 terabytes, and then we have the compute optimized and the compute optimized with GPUs. So it's possible that AWS will add options over time. I may not re-record this video, so that's fine. I always cover what's at the exam, so don't worry. And so as you can see, we have several options, and we see in the previous lecture the use case for each option, so I won't go over them. But this is a nice way to know what you're getting. Okay, so let's say we go, for example, with a compute optimized Snowball Edge. Then we need to choose a pricing option. So we have on-demand pricing, monthly pricing, or then commitment for 1 or 3 year period. Then we have the storage type. So it's an S3 data transfer. And then what AMI do we want to use on it? So this is a compute type of instance. So we can actually load an AMI, for example, this Amazon Linux 2 for Snow family. But you could create your own AMI to have your own compute needs. Then where do you want to load the data onto? So what S3 buckets are available to you? I have this one right here, but you can create your own S3 buckets. Next, we have several features and options we can use. So we have IoT Greengrass for Snow to have IoT capability on your Snow device, but it's not needed. And then we can do remote device management by using UpShub or the Snowball clients. So I'll click on Next. Then what type of encryption do we want on our Snowball device? So we have this encryption key right here, but you can create your own KMS key and encrypt it with that. Then you need to grant access, of course, to Amazon S3 and SNS to publish actions and to send data. So you need to create a service role. And then you need to add an address, so where you want to ship it, which country, which state, and so on, as well as the shipping speed. and the SNS notification for your job status changes. And then you'll get the job summary. So that's it. You've seen all the options for Snow devices and the Snow family. Remember, it's most commonly used to send data into Amazon S3 and out of Amazon S3, and this gives you remote compute capabilities. We've seen also the different kind of devices, which are Snow Cone, Snowball, and Snowmobile. All right, that's it. I hope you liked it, and I will see you in the next lecture. So we've seen Amazon S3 as a standalone service, but it is possible for you to use it in a hybrid cloud type of setting. So AWS wants you to bridge between your on-premises environment to AWS, and that's called hybrid cloud. So part of your infrastructure is going to be on-premises, and the rest is going to be on the cloud. Why? Well, maybe because sometimes you have created, for example, your on-premises infrastructure first and you're doing a migration, but it could be long, so you can do a long cloud migration, or for security requirements or compliance requirements. Maybe it's your strategy to have part of it on the cloud and part of it on premises. You have really different use cases for trying to have two different ways of doing IT, some of it on premises and some of it on the cloud. And Amazon S3, it's a proprietary storage technology, so this is not something like the EFS service or NFS protocol we saw from before that we can use directly onto servers on premises. For exposing S3 data on premises, you have to use something called a storage gateway. So if we wanted to summarize the storage options on AWS, the block storage would be EBS or an EC2 instance store. The file storage would be a network file system, so Amazon EFS, and object storage would be Amazon S3 or Glacier. And where does the storage gateway fit in all this? Well, the storage gateway is going to be bridging your on-premises data and cloud data in AWS. So your hybrid storage will allow your on-premises systems to seamlessly use the cloud to extend the storage capability. So this can be used for disaster recovery, backup and restore, or tiered storage. There are different types of storage gateway. There is a file gateway, there is a volume gateway, and a tape gateway. Now, you don't need to know all these types going into the exam, okay? What you need to know is that the storage gateway allows you to bridge whatever happens on premises directly into the AWS cloud. So under the scene, the storage gateway will be using Amazon EBS, Amazon S3, and Glacier behind the scenes, okay? So from a certified cloud practitioner perspective, the storage gateway is a way for you to bridge your file systems and your storage on premises into the cloud to leverage best of both worlds, okay? For if you were to do the AWS Certified Solutions Architects Associate course, you will need to understand storage gateway a little bit better, but I will save you this right now for the Certified Cloud Practitioner. Okay, that's it. I hope you liked it, and I will see you in the next lecture. So now let's summarize what we've learned about Amazon S3, and I know that's a lot. So first of all, we've learned about the difference between buckets and objects. So we know that buckets must have a global unique name, and it's tied to a specific region, and objects live within these buckets. For S3 security, we've seen that we can attach IAM policies to users or to roles. We've seen that we can also use S3 bucket policies. For example, we granted public access into an S3 bucket, and we can set up S3 encryption to protect some files. We can enable websites on an S3 bucket. This is the idea to host a static website on Amazon S3. You first need to make sure that the bucket, of course, is going to be public, and then we can statically host some files. We have S3 versioning. This is to have multiple versions for a file to prevent against accidental deletes and to be able to roll back to previous versions if we need to. We've seen there are two kinds of S3 replication. You have the same region replication and the cross-region replication. And for them to work, you must enable versioning beforehand. We've seen the different S3 storage classes. We have standard, infrequent access, one zone infrequent access, intelligent tiering, and we have 3 different classes for the Glacier for archival purposes. We've seen what the Snow family is. So there are physical devices that are used to import data onto Amazon S3. So you have like the Snowmobile, you have the Snow Cone, you have the Snowballs, and so on. And if you use a Snow Cone or a Snowball Edge device, then you can do edge computing on your data. Ops Hubs is a way to get a desktop application to manage your Snow family devices and add data onto them. And finally, we've seen a way to extend on-premises storage onto Amazon S3 that is using the AWS Storage Gateway. So now it's a big lessons, but hopefully now you know all the specificity of Amazon S3 that will allow you to answer all the questions you need at the exam. That's it. I will see you in the next section.